Okay guys, welcome back. We're going to do question number 2 from the same handout, RLC Parallel. Question number 2, Unit 4, handout 5A. Now, the first thing I need you guys to notice is that the capacitor is in microfarads. I've taken the liberty to figure out how many ohms that is using the formula for calculating, capacitive reactance, 79.58 ohms. The other thing I want you to notice is that this is 120 volts, so the voltage was given to you in the question, so that's the voltage you should use. I said it in the last question, if there is no voltage, make one up. It actually won't change any of your answers if you'd make up your own voltage. And that's because, on this question here that we did the last time, the total impedance, changing the voltage will not change how many ohms this circuit is. Okay, it'll change all the currents, but the ohms will be the same. So you're just using the currents based on a voltage you chose to calculate, an imaginary total current, and then you're going to use the voltage you chose and the total imaginary current that you got with that voltage to use, to calculate the ohms. And if you use 10 volts or 50 or 25 or 70 or 80 or 90, or it doesn't make any difference, you will get completely different currents, but you will get the same impedance, the same angle, and you'll have the same answer for leading or lagging. Now on this question, because the voltage was provided, you must use that voltage because it actually asks you for a whole bunch of currents here. And those currents are going to be dependent on what voltage that's being applied on the circuit, okay? So don't worry about it. Use 100 volts if you want to. For circuits that have no voltage, use the voltage that was given, if there is one given. We're going to solve this exactly the same way we solved the last one, and that is by not using an impedance phasor diagram, by calculating the 3 currents, by drawing a current phasor diagram, calculating the total current, and then using Ohm's law to figure out Z. So let's do that. This is going to be IXC, and it will be 120 over 79.58. Okay, I'm going to be a little bit quiet here. I'll just calculate all 3 currents using Ohm's law. Okay, so just used Ohm's law, calculated the 3 currents. Now I'm going to draw those currents as phasors and see if I can calculate the total circuit current. And by the way, look, we've answered some of these. Okay, so here's going to be my current phasor diagram right here. And again, since this is parallel, we're going to compare them to the voltage. And I'm going to draw IR on the bottom. It always goes on the bottom. All right, so nice big long IR. Okay. IXL, got to be drawn so it is lagging by 90, so it's down, and it always will be for a parallel circuit. Okay. We're going to draw IXC, 1.508, which means it goes right here. Okay, this goofy little line right here, it's going to be IX. It is going to be 2, the bigger number, minus the smaller number, okay guys? So 2 minus 1.508 equals 0.492 amps. That little thing right there, okay guys? And I'm going to get the purple marker out. I haven't had that one out yet. Let's try that. The resultant, a line that starts here, ends at the end of the last one. So there it is. That there is I total for this circuit. The phase or sum of all the currents is going to be equal to, look at this marker. Woo! 4 squared plus 0.492 squared. Ooh, sharp. Okay, 4 squared plus 0.492 squared equals root 4.03 amps. All right, so that's going to be this 4.03 amps. You know, Z is the first thing it asks you to calculate. It ain't the first thing you can calculate. All right, do not be tempted by this Z thinking that you can go, you know, I've said it before, I'm going to say it again, thinking that you can go 30, 60, 79. No, okay? The only way to calculate that is after you've calculated IT. So it is going to be E total over I total. It's going to be 120 over 4.03. Try that again. 120 divided by 4.03. It is 29.78 ohms. All right, guys. Phase angle, opposite over adjacent, inverse tan. 0.4924. I'm getting 7.01 degrees. All right, and yeah, it looks pretty shallow. I mean, this is really short, this little side over here, right? Leading or lagging, guys. There's your circuit current. You identify the current phasor. Decide if it is clockwise or counterclockwise from the voltage phasor. It is clockwise, so it is lagging. All right, now, before we leave this, there is one other method that you can use to calculate or figure out whether the circuit's leading or lagging. It's what I call the Nascar method. All right, guys? And the Nascar method is this. Imagine a NASCAR track. Okay? The finish line is right there. Let's take a look at this guy. Imagine that the voltage is here. So this is the voltage car. Here's the current car. Okay? Voltage, E, I. Who's lagging? I mean, in NASCAR, everybody turns left all the time. If you don't watch NASCAR, you don't know that. But if you watch NASCAR, you know that everybody turns left in NASCAR. Okay, so here's the finish line. The voltage is leading. The current is lagging. This is asking, what is the current doing? He is lagging. All right, so NASCAR. Imagine all these guys whipping around. Here's the finish line. This blue line is leading. That purple line is lagging. All right, and this is asking about the purple line. It's asking about the current. If I took a look at this one, NASCAR. Here's the current car. Here's the voltage car. The current is leading. Here's the finish line. All right, guys? It even works in series. Let me see if I can find a series circuit from my millions of notes that we've already taken. Probably not. Okay, hold on a second. Give me a sec here. Here's one. Okay, guys? So, look at this was a series circuit, but it works for this too. Here's my NASCAR track. Everybody's going around this way. There's the finish line. There's the center of the track. Here's the current. There's the voltage or the impedance. If there was a voltage phasor diagram, it would be there. This one, the current is lagging, which is why we chose lagging. He's losing. Okay, everybody's trying to get to that finish line right there. Current, lagging. All right, so works every time. As long as you've drawn the phasors correctly, you will be able to tell whether it's leading or lagging using the NASCAR method. But that's totally up to you. You know, a lot of students go with the 50-50 method. They flip a coin. All right, whatever. It's only one mark. Who cares? All right, and that works too. You get 50-50 chance. But I don't know. There's better ways. Either way, have a good one, guys, and Take care of yourselves, all right? See you soon.